Hey guys, my name is Cherno. Today, I'm going to be showing you how to properly set up a C++ project, especially one that has this kind of core app architecture, which basically means that you have this core library of code and then one or more applications that will use that core library. Now that by itself is obviously extremely subjective. Everyone has their own way of doing things, and in this video I'm going to be showing you my way of doing things. And the use cases for this core app architecture are honestly endless. You could use this for so many things. I use this architecture when making Walnut Chat as an example. It's like an instant messaging chat client thing. And even Hazel, my game engine, uses this same architecture. In fact, it's a very, very good fit for game engines. So in this video, we're first going to take a look at how to use this template to make a brand new C++ project, but then I'm also going to be showing you how to retrofit an existing project and conform it to this architecture and to this template. And we're specifically going to be doing that with the 2000-hour 2D game engine that I have been code reviewing as part of my code review series for like 3 videos already, because this will greatly improve that. Now, typically when people make new C++ projects, if they are either new to programming or to C++, or they're inexperienced or whatever the reason might be, a lot of the times they will just open Visual Studio as an example, or whatever IDE they use, and they will click the new solution, new project button, whatever, and just they'll start from there. It seems logical. Like, I don't blame anyone for doing that. It seems logical, and for a lot of cases I'm sure it's fine, but there's a better way. By using my template. This sounds like I'm selling this template. This template is completely free. The link will be in the description below if you want to just skip me talking. The problem is that with C++, most of the time, you want to be using a build system. Now, a build system really, like, it's a term that has many definitions potentially, because a build system, as the name implies, is supposed to basically take your raw code files and build it into some kind of product. Now, an example of a build system is CMake. CMake will do that. I prefer to use something different called pre-make. The name basically explains what it is. Pre-make. Make itself is a build system. The whole idea of make is that you have these things called make files. You use them to describe what your project is and how it should be built, and then you run make to build the project. Pre-make exists as a way to generate make files, because make itself is kind of an interesting build system / language, and it can be very verbose and potentially difficult to express yourself in make versus something like pre-make, which just uses Lua and is much simpler. Now, pre-make doesn't just generate make files. Pre-make also generates, well, any kind of project file you really need. So for example, if you want Visual Studio project files because you're going to be compiling your application or your project on Windows, pre-make can do that for you. It will take your Lua description of your project and it will generate Visual Studio project files and solution files for you. Hopefully you're beginning to see the power now, because if I instead want Xcode files because I want to build this on my Mac, or I want, I don't know, make files because I want to build on Linux, I can do all of this. There's plenty other supported build systems and IDEs as well. So that now means that instead of me having to create project files in Visual Studio by using the UI and then having them only work on Windows, or at least only work in Visual Studio, I can create all of the build configuration files for my entire project in pre-make and then have pre-make generate whatever project files I need. So that is what pre-make is. We've been using it since the beginning for Hazel, and it's been really good. And this template also uses pre-make to generate all of the project files, which is one of the reasons why this template is a fantastic starting point for cross-platform applications. Now, before we dive in and take a look at this template and I show you how to start a brand new C++ project using it, if you want to learn computer science and math, then there's an excellent free way you can do that with the sponsor of this video, Brilliant.org. Brilliant.org is an amazing website filled with lots and lots of courses on various STEM topics. Now, as I mentioned, they're an excellent place to start learning computer science because all of their courses are just really clean and fun and efficient at teaching you. Instead of just watching like boring lectures with zero engagement, you instead have these widgets that you can play with that show you how things work. I think their math courses are a fantastic example of this, because you can see, like, for example, with calculus, how stuff works visually, and you can play with it to see how the numbers actually reflect how it works. But then also they'll quiz you. They'll ask you questions to make sure that you are actually learning something and that you can answer those questions. And the range of how advanced their courses are, they go down all the way to the beginning with the everyday math course, which is a fantastic place to just ease into math, all the way up to like linear algebra and calculus. And guess what? You can take a look at all of this for free. Brilliant have a 30-day free trial that you can use to check out everything they have to offer. Just go to brilliant.org/the Cherno. Link will be in the description below. And if you do go on to like it, Brilliant have been nice enough to offer the first 200 subscribers 20% off an annual membership. Huge thank you to brilliant.org as always for sponsoring this video. Okay, so here is the C++ project starter template. The link will be in the description below. I've spent a little bit of time here on this README so that you can read it. That's what a README is for. But the easiest way to use this is to click this use this template button, because that just lets you create a new repository with this as like the starting content. So let's actually go ahead and do that. I'm gonna just call this new project. I'll make it private. I'll click create repository. This won't take very long. And then here we have our brand new repository. It's called new project. It's generated from project template. And now what I can do is I can just clone this. So I've got this local folder here. We can just do git clone and then paste the URL. There we go. We've got all of it. Let's open it. And this is it. You're ready to go. So the most important thing you need to know is that inside the scripts directory, there is a setup Windows batch file. There's also one for Linux as well. I didn't get around to making one for Mac OS, but I'm sure that's not too difficult. So all we have to do is just double click on this batch file. You can see it's going to run pre-make here. And then if we go out, you'll see that we have a new project solution file. So this is in the root of this project. So if we open it, here we have in Visual Studio what this looks like. So we've got an app project. We've got a core folder. Inside the core folder, there is this core project. We've got some example files, just some starter content. So inside app, you can see I'm just calling something from core, a function called print hello world, which will just do this. So if we just hit F5 on that, there you go. We've got an application. Mind-blowing, I know. Now hear me out. I actually think this is a lot faster than if you set this up in Visual Studio yourself. If you did set this up in Visual Studio, there'd be a lot more clicking and it would be Visual Studio only. Whereas with this template, we have this great architecture here where you can see app references core. So I'm ready to go on that front. I have debug, dist, and release configurations already set up. And as you saw, I can also generate these project files on Linux just into make files and then use make to build this, or I could really generate whatever else pre-make supports. So that's kind of it. That's ready to go out of the box. Now you might not want this to be called new project. So how can we edit this? And how does it work in the first place? So in the root, we have this build.lua file. By the way, the GitHub README explains all of this, so you can just read that if you want. But since we're here, I'll show you. So build.lua, if we open that up, you can see, I should probably get rid of this comment. Whoops. You can see that we have a workspace definition. So this defines kind of like our Visual Studio solution. You can put some workspace-wide build options here. I've just put some ones that we commonly use on Hazel. You can set a more custom output directory because by default, it'll be in binaries and then the platform name, the configuration name, and then the project name. So if you don't like that, you can change it here. Here are the solution configurations and the architecture and the start project. If you want to change this to some other name like orange, let's call it project orange. If we go back to the root here, we have app and core. So if this was my, like, I don't know, orange core, let me just maybe close this first. And orange app. Inside these two folders are where those projects go. So my core project is in here. Here's that VCX proj file I generated from earlier. Here's all of my source files inside the source directory. And here is the Lua file that tells Premake how to build this project or how to generate project files for this project. So if we open this up inside a text editor, then here we have all of the project specific configuration. So here's the name, for example, it's called core. So let me change that to orange core. That might be something you want to customize. The version of C++, as an example, you could also change this, by the way, to C#. So this doesn't just have to be used for C++, but that is the common use case for it. Which files you want to include. So I might actually change this a little bit because at the moment it only supports H and CPP, which is what I use commonly. However, if you use like HPP or CXX or you want .c files as well, like you can add all of these here. Might make more sense to make it into something that looks like this in that case. There's the compiler include directories here. I mean, really, if you want to set this up, you can see that there's specific things for Windows or specific settings for debug, release, or distribution configurations. If you want to see what's possible, you can just check out the Premake documentation. I'll leave a link to that in the description below. So that's orange core. If we go back out, we have orange app. same story with that as well. You can see that we have a project called app, which I can rename to Orange Core. You can see, by the way, that this is a console app, whilst Orange Core is a static library, and also Orange app, which I accidentally called Orange Core, links to core. So we need to update this as well, because that's the name. And then if we want the include path to also work, we have to update that. You can also just use variables, that's fine, but typically project names don't change that often, so I usually don't bother. Okay, so now back in the original build file. So this is like the one for the solution or the workspace. We just need to make sure that we're including the right directories here. So we can call this Orange Core and Orange App. And if I go back and just rerun that setup file, it should regenerate all the projects. Now you can see I have Project Orange being the solution file. And then if I open that, I have Orange Core and Orange App. The one thing I did forget to change is the start project. So over here inside the build, you can see the start project is still app. That's why it incorrectly set this one as the start project, because it didn't find one called app. So let's get rid of that. And then if I just delete everything, all of the generated project files, and rerun this, open up the solution file, then you should see Orange App as the startup project. And we should be able to run this as normal. Okay, cool. So yeah, that's really all there is to it. It's just a really nice starting point if you want to have a C++ project with this architecture. And so now let's have a look at how we can apply this to an existing project which is not using this. It's not just using no build system or no project generation system, just raw Visual Studio project files. It's also not using this architecture at all. There is no app and core distinction. It all becomes part of a single Visual Studio project. So we're gonna apply this to that and fix all of that up and hopefully make it a lot better. Right, so here we have the project that we're gonna be applying this magic to. This is the 2000 hour game engine that I've been code reviewing as part of my code review series. Link to this project will be in the description below. Again, we're just using it as an example because it happens to not have this architecture implemented and also doesn't happen to have a build system at all implemented. So I've checked out the project locally. Here it is on disk. This is the root of the repository. If we go into the engine folder, there's just a sprite engine solution file. And if we open that, we are greeted with this. So we have a sprite engine project, just a single project in this entire solution. And then inside here, we have the engine, but also this project itself. If we take a look at the properties, you can see it builds into an executable file, and this is the editor for the project. So you can see here, if I look at the main file with the main function, it starts off with a UI project selector, and this is where you can open whatever project you want, and then it runs the engine and essentially the editor for this engine. Now, what about the games? What if you want to just run the game? So inside the resources directory and template, there's another solution called assets. And if we open this solution, you can see that it again has a single project and it's just called assets. And that has some kind of subset of the game engine's source files. So you can see there is also a main file. Looks similar, but it doesn't have that UI project selector. And then if we open up the base engine solution, which is the editor, if we take a look at these source directories side by side here, you can see that this one doesn't have, for example, a GUI components section at all. And I think everything else looks pretty much the same. But see, like in manager, there's a GUI manager here. I don't know if it's just in a different, okay, so it's here, but it's not included, because I'm in show all files mode, sure. So there are some differences, as you would expect, because one of the project files builds into the runtime, one of the project files builds into the editor, so there have to be some differences, and they're definitely here. But what's really annoying about this approach, which I talked about in those code review videos, is basically the fact that since you have two different projects, all of these settings are obviously per project, right? So these settings and these settings, they're two different projects that need the exact same settings, more or less. Anytime you want to link a new library, anytime you want to add an include directory, anytime you want to add like a preprocessor definition, that has to happen in both of those projects. And in fact, every time you want to add a file, I just want to add a new CPP file. Well, if you want it to compile for both the game and the editor as part of the engine, then you have to manually add it to both project files, which is very inconvenient. So part of the way that this core app architecture helps you here is that we can group all of this common code into that core project and then have two different app projects. One, which is this assets project, which is the game's runtime, and then one, which is this sprite engine project, which is the editor. In those projects, that falls under the app project category. We would have things that are specific to those applications and those projects. But then everything else that is core, that is central to both of those applications, would be inside that core library, inside that core project. Now, as an example, when we have something like GUI components, which is specifically part of the editor in this case, because it doesn't exist over here inside the game project, that could simply just live inside that app project that we'll make, not inside core, because it's not going to be central. In more specific setups, this hierarchy of like we have core and we have app can definitely be extended, by the way. So you could make another static library in between core and app that's called like GUI components. And then that way, if you do need to reuse that code, you can reuse it in multiple applications. So maybe you have an editor, but then maybe you also have some kind of other tool that needs to use GUI. That would be a great example of making like a GUI components project in between core and app so that you can reuse that code. And then the game project, which doesn't need that, would simply directly link to core. So again, I want to stress this template is just a starting point and you can definitely extend it. Okay, so here we have my project template. All you have to do is clone that somewhere. I'm not going to spend too much time on this here because we've already covered this earlier in the video, but here I have the physical files on disk. What I'm going to do from here, just as a starting point, is just copy all of these files into this Sprite Engine UI project. I'm going to have a look here as to where I want this to live, because there's this GitHub directory with a couple images, and then there's the engine. And I'm assuming this person is treating the engine as like the root directory. So I think this would be a good place for this to be pasted into. We don't need the git ignore and the readme and the unlicensed. I'm just going to delete all of that. So now we can really begin customizing this stuff. So the source directory includes all of the stuff that is relevant to the engine, but then there's also this Sprite Engine file and GUI components, which seems to be only relevant for the editor. So as a starting point, I'm just going to grab everything inside the source directory, cut it, put it into core, and then source. I'm going to delete this starter content that we had here, paste that in there. So now it's in here. Now I'm going to rename core to Sprite Engine core, and then app, I'm going to call Sprite Engine editor, and I'm going to copy and paste that folder and just call it Sprite Engine runtime. So we've got the core, we've got the editor, and we've got the runtime, 3 different projects. Now, if I open this build.lua file in a text editor, that's the one that's in the root of this project. I've got a group here called core, which runs build core. We've changed this directory name, so I'm just going to make sure we do that. And then we've got Sprite Engine editor and runtime. So I'm just going to make sure that we have 2 of these. One's going to be inside Sprite Engine editor. I might call this something like build editor. So we'll have to rename that Lua file as well. And then we also have Sprite Engine runtime, and I'm going to call this build runtime. Other than that, that looks pretty good. I'm pretty happy with that. The start project, we might make the editor, so we'll have to name the project that as well. And then coming back into here, let's start with core. I'm going to go ahead and open this. So over here, let's go ahead and call this project Sprite Engine core. By the way, we should probably name the workspace something. I'll just call it Sprite Engine. So what I'm doing here is I'm making a workspace, but I've got 2 different projects tied into that workspace. Well, 2 different executables and then 1 core library. You could make 2 different solution files as well if you wanted to. You could just have another workspace called like Sprite Engine runtime and then another one called Sprite Engine editor. That way you don't have to have them all inside one solution if you don't want to. I prefer having them all inside one solution because then you can easily switch between the editor and the runtime as you're developing the engine. So I'm going to leave it this way, but if you wanted 2 different solutions, you could also set that up pretty easily. So here's Sprite Engine core. That's going to be a static library. I'm just going to include everything inside here. I'm going to set it as an include directory. Most of these settings are pretty straightforward and universal. Like I don't really need to change anything at all. So if we go back now, I just need to make sure that build core is called the right thing. So it is build core, but then we'll have to just rename editor and runtime. This is called build app. So let's rename it to build editor.lua. We'll go ahead and open it. The project name, I'm going to call Sprite Engine editor. It's going to be a console app. Now, if you wanted to, you could make it so that under filter distribution, it was set to windowed app. So I actually had to open up the pre-make documentation here, but you can see these are the possible values of kind. So we're using static library. If you wanted a DLL, you could use shared lib instead. And then console app is just an application with an actual console being allocated. And then if you didn't want that, you could have it set to windowed app. So Hazel, for example, has release and debug set to console app because we use those 2 configurations in development, but then the distribution configuration is set to windowed app. So that's where these filters really do come in handy as well. Now we have to include the core directory if we want to be able to include those files. So I think the directory is just Sprite Engine core. And I think that's like, for now, that's probably it. If I go back, we'll just have to do the same thing with the runtime. So we'll call it build runtime. We'll pop that in here. And then I'll just make sure that we have that same include directory as well as the project being called Sprite Engine runtime. The other thing is what it links. So it needs to link the Sprite Engine core project. So you need to get that name right, obviously. So Sprite Engine core is what both of these guys need to link. And then I think that's it, honestly, for the project configuration. If you separate the files into their proper directories, meaning the stuff that's relevant to the editor you put into editor and vice versa, you shouldn't really have to do anything specific here. Another thing we could have done is just ignored certain files. So you can include an entire directory, but then exclude files as well. That can be useful under certain configurations if you don't want to include debug files inside a dist build, for example, but we're not going to cover that here because it's just not relevant. Back inside core, I want to have a look at the GUI components and then also this sprite engine file, because this sprite engine file is the thing that launches this UI project selector because it's the editor. So this obviously shouldn't be in core, it should be inside that editor project. So I'm going to grab sprite engine.cpp and GUI components, this file in this folder. I'm going to cut this and I'm going to put it into sprite engine editor source. So we'll delete app.cpp, which is just like the starter content, and we'll paste that in. I'd probably rename this file to something like sprite engine editor as an example, but this is what contains the main function for this executable project. So that's inside source, that's great. Now we need to do the same thing for runtime, but remember that's inside like resources template engine, I guess, source, and then here's the main. So I'm assuming these are the same. Like we might have to grab header. I don't know if header's necessary, but let's grab main. I'm just going to open up another view here. We'll go back to sprite engine runtime source. We'll delete app. We'll paste this in. We'll call this sprite engine runtime instead of just main. Now going back here though, header. Was header something that we had inside the core engine? No. So I'm assuming we probably want that. I don't know what's inside there, but I can see that it's just in the runtime. So we'll paste that in and we'll see what happens. That was probably an include directory. By the way I'm doing this is like, this is a fairly small project, so I don't really need to stress too much. But if I was trying to do this a little bit more accurately, perhaps, there's a couple ways I could go about that. First of all, if we go into this template solution, I could open this as well as dropping in this VCX proj into a text editor just to see exactly, what files are included in the build, what preprocessor definitions there are for various things. It's potentially a little bit easier to just look at the text here, and you can see, like, for example, what it links, which we're going to have to set up as well, obviously. But you can also do that just using the UI if you prefer. So if I go into C++, there's additional include directories, and you can see these are the include directories that are necessary. So I obviously need to make sure that these are all set up correctly, as well as inside linker, there's going to be the additional library directories, which I'm going to need to include as well. And then under input, there are all of these files, all of these library files that need to get linked. And there are different variants. So you can see these have /d for debug, but then if we switch to release, there's no -d. Sorry, I said /d, I meant -d. That's not in these ones. So that's another example where we would use filters. But before we do linking, let's do compiling first. That's a good way to break this down. Otherwise, it's just too much at once. So in this runtime project, if I just go over here, I know that I'm going to need all of these directories included, and that's going to be relative to the solution directory, which is this directory over here with that solution file. So we have engine, and then we have the source directory, and that's included, as well as source include, as well as scripts, as well as source include IMGUI. So let's go back to build runtime over here. I'm just going to move it here so I can see these two. And then into this include directory, I've already got sprite engine core source, which is this directory up here. So let's duplicate that a couple times, and we're going to have source include. Now this scripts directory is not part of the engine, it's inside assets. We'll take a look at that in a minute, but we also have source include IMGUI as an include directory. So we'll add that. And then we have scripts. So what on earth is in scripts? Scripts doesn't actually exist at the moment. Scripts is probably the directory for like user scripts. So if your game has custom CPP files, I imagine that's what that is, because I think C++ is used as a scripting language. So if you wanted that, you could of course also have this here as an example. So I'll just leave that for now. And then let's also make sure that we have all of the ones that are inside the engine. So if we open up the engine solution and we take a look at these property pages, then we have all of these guys. So let's go ahead and include all of this. And you can see there's some stuff here that's relative to GUI components and some stuff here that is relevant to the actual engine. So this is also, by the way, where I should mention that it can get a little bit difficult to discern what is part of the engine and what is part of the app. So what's core, what's app, because they're all in one project, right? So I actually don't know if include IMGUI, for example, is necessary for the app. Like it might just be something that the core library needs. And same with include, like I don't know. Include sounds like it should be included, source, I guess, as well. But if we go back into the core, what I'm going to do is make sure that we also have source/include and source include IMGUI and source headers. So source include IMGUI and source headers. So we're putting these include directories into the actual core library because I'm assuming that the CPP files there would need these include parts to build. And then if we go into the editor configuration file, then these GUI component ones are probably going to be there. And again, some subset of these, possibly all of them, I don't know. So let's just add, I guess, all of them. So source include IAMGUI, source headers, and then we have a bunch of stuff that's GUI components, which remember is in our project now, not inside core. So source, GUI, components, property, editor, real-time editor, project selector. Okay, that looks good. If we take a look at the preprocessor, so again, I'm just focusing on compiling first, not linking yet. So this tab is what I'm interested in, not the linker. So inside preprocessor, I also want to make sure that these are set, I guess, debug and console, and then we have debug and console. I don't know if they're actually used by this project because these are kind of Visual Studio default preprocessor definitions. But if you wanted to add these two, then obviously into either debug or release, we could add them. So for example, release, see, I've got release as just a default define, but it doesn't look like we need it. So we can just replace it with debug. And then this one would have underscore debug, and then dist. We don't really have a dist to begin with. And then there's also underscore console that's used in all of these configurations. So we could just pop it down somewhere up here like so, and there we go. So let's make sure that build runtime also has this and build core has this. And then this debug underscore debug stuff, I'm also going to make sure that we have inside the other projects. And I think that should be it as far as compiling goes. Obviously it's not going to link, but it should be a good starting point. So if we go back to the root and actually inside the engine directory where we have this scripts directory, if we go ahead and take a look at what setup Windows does, you can see it goes back a directory and then calls this. The file it's going to run is build.lua, and it's going to generate Visual Studio 2022 solution and project file. So that sounds pretty good. I think that should probably work. So let's go ahead and run this. There we go. So you can see it's generated core, editor, and runtime project files, as well as the Sprite Engine solution file. So if we go back, we now should have Sprite Engine with a space, which is good because otherwise it would have overwritten this one. So let's double click on this, and this is our brand new solution. So over here, you can see we have Sprite Engine editor as a start project, which is great. We've got core with all the stuff that's included inside core. And then we've got editor just with GUI components and this Sprite Engine editor file, as well as Sprite Engine runtime with that header directory, which I don't know if we actually need, but sure. And then we've got Sprite Engine runtime here as well. So we've got a few errors, it looks like, but let's go ahead and build core first of all. I'll right click and hit build. Again, this isn't going to link at all because this is just a static library. So we're just going to make sure that our stuff is set up correctly, which you can see it's not. So UI tool buttons model seems like it's necessary by Sprite repository, which is weird because I thought that it wasn't being used, because I guess this is something that is inside GUI components, but it's also inside Sprite repository, which is a very core file, as we learned from the code review videos. And see, there's like editor tools in here. So this might require a little bit more work to actually properly segregate. But what I want to do is I want to go back to this template, because are these files actually different? Imagine if they were different. So Sprite repository.h, it's located over here inside manager. Let's take a look at it here. Oh man, it's a different file. Look, it doesn't have that. These are full on different files. Okay. So that's definitely putting a dent into this. I mean, they're probably not that different, but you can see editor tools isn't included in here. It looks like it's basically the same thing, but editor tools, you can see, is not in here. Now, I'm expecting that the CPP file is also going to be different, because obviously if this is a member variable, I'm assuming it's going to be used here somewhere. If we go back to core and we take a look at Sprite repository.cpp inside core, you can see there's current tool. And then, well, it's not really used inside here, but it is set here. Now, fundamentally, I have no idea why Sprite repository, which is supposed to be essentially a data structure, would have an editor tool inside it. That, again, is not a very good design. And you can see why. It's leading to problems here where we have to have two different Sprite repositories where the only difference really seems to be this current tool. And there's also this initialized kind of word that's missing, and otherwise I think they're pretty much the same file. I could definitely make an entire video talking about how to set this up properly so that you could have specific variants potentially of this that only were used for a particular project but then not another project. So for example, like for the editor but not for the runtime. Now there's some other problems here. And you can see that actually a lot of this seems to just rely on this GUI components, even though I really thought it was excluded. Let's go back to the template for a second and we'll open up this solution. Did these just not have any mention of GUI? There's GUI manager here, but I guess that doesn't, but I guess GUI components, yeah, it doesn't exist inside the solution. Wow, so every single file that was in here has a variant, has another copy of that file that just has this stuff manually stripped out. Which means that if you update any code inside game engine, what? So there's two different game engine files. Sorry, this is turning into a bit of a code review, but if I go back into here, and this is gameengine.h here, it just doesn't have that. What? So these are just fundamentally different. What do I do here? I actually don't know what to do here. So I guess this is a good example of where it can be a little bit difficult to retrofit this core app architecture when you have gone down the two different paths too far. I think from here there are a few different approaches you could honestly take. The better solution would just be to set this up completely differently, where you don't have two identical classes that have to have different code depending on if it's the editor or the runtime, but instead all of your truly common code, like this renderer, I mean, you can see even just the namespace is different. Well, actually no, they're both in that namespace, but this just has this for some reason. But anyway, you would have the common functionality inside, say, game engine, and then the stuff that is relevant to the editor would just be in like the editor application file, which could be a number of things. It could even be a subclass of this. It doesn't have to be. But yeah, I honestly had no idea that these files were so actually different. I just thought this project had a different subset of files. So if we paste back this GUI components as an example, and let's just go ahead and rerun the setup script to regenerate this project. I'm assuming now it will probably build unless we need, yeah, so you can see there's also the include path here. So going back into core, we need to make sure that I guess all of these are also include directories inside core if we wanted it to build. And then let's rerun that. And then let's try and build that. Okay, so I've got an error over here now. Okay, I have real-time editor here for some reason. Whoops. Let's rerun that again. And there's some other errors that we have here to iron out. I think this is upset about char 8t because this is a U8. It's probably a C++ version thing. One thing I forgot to mention is that this we set to C++ 20. Right, so that the template by default comes with C++ 20 as the CPP dialect, the CPP version. But if we look at the original, it's C++ 17. So that's definitely something you want to get right. Otherwise, you might have issues like we are seeing here. So let's regenerate that again. If I try and build this file, you can see this file succeeds. Let's try and build the rest of the engine. We're getting there. We're getting there. Do we have any errors? No. Here's GUI seems to be building as well, which means our include directories are set up correctly. And there we go. We've successfully built this as a static library. So I hope this was helpful to you if you want to retrofit this potentially into an existing project. There's still quite a bit of work for this specific project to get it to work properly with this new architecture, considering that it is just a mess when it comes to the way that it's set up to eventually build into two different products. If you would like to see more videos on me fixing this project and bringing it into this architecture and just setting it up properly in this more robust way, definitely let me know in the comments section below. But otherwise, I hope you guys do enjoy my template. If you enjoyed this video, please don't forget to hit the like button. The link to the template will be in the description below. It's just freely available on GitHub. And the license is just unlicensed, so feel free to do whatever you want with it. Don't forget to check out brilliant.org/thecherno, and I will see you guys next time. Goodbye.